defined as a package of data elements, guidelines, and instructions for creating library and cultural heritage resource metadata that are well-formed according to international models for user-focused linked data applications. So that's the definition of RDA from the RDA agreement in 2018, and this can be found on the RDA Steering Committee's website. So as you can see, linked data is baked into what RDA is. So whatever RDA does, it has to be developed so that it will work in a linked data context. So this slide is describing the RDA stack, and this is sort of the diagram overview of how the infrastructure of RDA works. And we'll get into each of these different components in a little more detail later on in the presentation. At the top of the stack, we have the ALA Staff Registry. The ALA Staff Registry is used to generate the content for RDA Vocabularies, which is our GitHub instance. We then use the information that is in GitHub to generate various other things for other things in the RDA infrastructure. So the big thing that everybody will notice is the RDA Toolkit content comes from GitHub. Information that is used in RIMF comes from RDA Vocabularies. We also use the information in GitHub for the RDA Vocabulary server, that's our dereferencing service. And finally, we use the information in GitHub to run the RDA Registry, which is intended for developers. So we'll get into each of these, some of these components later on in the presentation. So we will start with the ALA Staff Registry. And this is the password protected repository of the RDA element sets and value vocabularies. So in comma separated value files of the element sets and the value vocabularies, these are maintained offline by the technical team liaison officer, that's me, and the RSC secretary. So when we're ready, we amend those CSV files. When the amended CSV files are ready on our end, we upload those to the staff registry. Then what we do in the staff registry, it can output the element sets and the value vocabularies in various serializations and in CSV format for RDA Vocabularies, our GitHub project. And these are used in the production of RDA Toolkit. Finally, the ALA staff registry is used to manage the translations of the element sets and the value vocabularies. So very briefly, I'll show you the user interface for this. So this is the ALA staff registry. And you can see here in the red circle, this is where we would take our CSV files that we maintain offline of the element sets and the value vocabularies, and we would import them into the staff registry here. Then the staff registry can output those into various formats. And for the GitHub instance, we want them in XML, NT, JSON, and as CSV files, so we can get those files. This part is showing how the translations are managed. If you're a translator and you have amended your translation files for RDA reference, you can upload them here. And also, then you can also get what you've already translated and what is still needed to be translated through the translation templates. So this is sort of the back end. You wouldn't ever be going to this website, and if you did, you'd have to have a username and a password. So moving on to the next part of the infrastructure is the RDA Vocabularies, and this is our project on GitHub, and our slide provides a link to that. And here it provides the element sets and the value vocabularies in RDF XML, N-triples, JSON LD, and CSV. RDA Vocabularies also provides maps and alignments to other vocabularies in Turtle, N-triples. Some maps are in RDF XML, and everything is in CSV. The reason why we have some in RDF XML, those maps are used to generate the maps and alignments to Mark 21, the IFLA LRM, and Dublin Core in RDA Toolkit. The maps and alignments are maintained offline by me. And when those are ready, when we're ready for a new GitHub release, I will upload the new maps and alignments. RDA Vocabularies also hosts the RDA Registry website. So anyone can go and visit our GitHub instance, and this is the landing page for RDA Vocabularies. And this is all intended for developers so that they can grab different releases of GitHub. The advantage of using GitHub is that everybody in developer world uses GitHub. It's a familiar product. GitHub also has version control, so we can go back. We can roll back to another version of RDA Vocabularies if we had to, if there was some sort of catastrophic error or a catastrophic problem. We could always go back to an earlier release. So this provides a way for us to do version control. Now moving on, I'm going to talk more about the RDA registry, and the URL for the registry is provided at the top of this slide. And it is the linked data and semantic web representations of the entities, elements, and terminologies approved by the RDA Steering Committee. So for those of you who are wondering how is this different, it isn't different. It provides the same content as RDA Vocabularies, our GitHub instance, but what RDA Registry does, we present those with context, and it's aimed at developers of applications using RDA. And the registry also functions as the endpoint of RDA IRID referencing for elements and concepts. So if you click on a link, an IRI for our concept, you will get taken to the appropriate page in the RDA registry. So it's our dereferencing service. So just show you, I'll just take you on a small tour of the registry. On this slide, we have our landing page for the RDA registry. And I'll just point out a few important areas that you might want to take a look at later. So the area highlighted in red here is the elements page. And so that would include the classes and then any of the agent properties, the work expression item and manifestation properties, the nomen properties, the place properties, the timestamp properties, and the RDA entity properties. We also have links to the unconstrained properties, which I'll explain more in a later slide, and RDA Onyx, and the RDA Onyx framework. We also have a link to the value vocabularies, and these are the vocabularies that are used in a lot of the attribute elements. So content type is a value vocabulary, media type is a value vocabulary. You can access those value vocabularies by going to that link. And then finally, these are the tools that are available for taking RDA data and either mapping it to another element set or for transforming RDA data into something that is not RDA. This is an example of the manifestation set, the manifestation properties in the RDA element set. And all of this stuff, all of this information is dynamically generated from the files in GitHub. So up at the top here, we have what we call the ontology metadata. So it provides a definition of the element set, how many active elements are in this set, the namespace, the version of it, a suggested prefix for the query. And this is all generated dynamically from what we have in GitHub. Down in this area are where we actually provide the properties, the definitions, and other information about the various properties. If you click on that double arrow, you can always expand and get more information about a particular element. So assuming that we have clicked on those double arrows, we would go to something that looks like this. And here I've taken the information for has identifier for manifestation, and I have expanded it out. And what do we have here? So we have a scope note that further defines what has identifier for manifestation is. It provides its domain, and then it also provides subproperties and superproperties of this particular element. So which elements within the hierarchy are lower than this one, and which elements are higher within the hierarchy. And we also have the toolkit label and the toolkit definition. The reason why we have these two different things is that the label has identification for manifestation, and the definition are intended for linked data applications, whereas the toolkit label and toolkit definition, that's the style of how that element appears in RDA Toolkit. And I also want to show you that this is a multilingual and multi-script site. So as an example of this, in the manifestation element set, this is the Greek translations of the elements and their labels. As you can see, it can handle this particular script. And for languages that do not read from left to right, we can also display that. And this is showing the Arabic translation of the manifestation element sets. And you can see here, you are able to read it right to left. Now, the table hasn't changed, but the definitions are in the correct orientation, as are the labels. And for the eagle item on you might see that within that box, the properties index, we have the navigation in the language that you are viewing. So this is one of the ways that we take stuff that's in the RDA vocabularies and we put it into GitHub. And we put it into RDA Registry, excuse me. So I want to briefly talk about why we use certain RDF serializations and in what context. So we have RDF XML files, and this is used, and these are used for the RDA Toolkit production process. We have a content management system that uses DITA, and we can feed the information from the RDF XML files into there to generate content automatically. So what's generated automatically? Well, the toolkit glossary is generated automatically, as are the element reference sections. Also, the element navigation is also automatically updated. So to show you what I'm talking about, here I went to the RDA Toolkit page for identifier for manifestation. So the definition and scope up at the top, as is the element reference, this is on the left-hand side of the slide. All of this stuff is generated dynamically whenever we do another release of RDA Toolkit from what's in the GitHub instance. And then on the right-hand side of this slide, you also see the related elements for identifier for manifestation. It's broader, it's narrower elements, and the inverse of it. And so once again, this is all content that is generated dynamically from GitHub. So going back to what we use our serializations for, the RDF XML is also used for the RDA vocabulary server. The JSON LD files, they're used for the element set and value vocabulary display in the RDA registry. So anytime we do a new GitHub release, that means we see that content will be reflected in the RDA registry. And we do this by various JavaScripts that have been developed by the RDA development team. And we have tried to use tools that are widely used across the web. So we use data tables, Bootstrap, and jQuery to display and to search this data. And finally, we have the NTRPL files. And these files are ingested into RDA in many metadata formats, also known as RIM. And that's an RDA training and small-scale production tool that is maintained by independent developers in liaison with the RDA development team. So a lot of you may be familiar with RIMF. We've used RIMF in a lot of Janathons at ALA, annual or midwinter, or in other sessions. So I want to get more into how linked data is used to make RDA data more linked data friendly. So I want to talk a little bit about the element set structure. So let's talk about the main element set, and that's called the canonical element set, and that's what everything else is based off of. So this is all the RDA elements and all the RDA elements, and they're provided in RDF schema. So we provide the domains of the elements, but we don't provide any range in the RDF schema. And that's because the values of those properties could be a literal or an IRI. The canonical element set also includes properties that are intended only for RDA Toolkit. So that's things like toolkit label, which is the label of the RDA element in a non-verbalized form. The toolkit definition, which is the definition of the RDA element that does not include the domain of the element. So what we mean by that is that the definition in Toolkit usually only is talking about the range of that particular element. In the regular SCOS definition, we say exactly what the relationship is, that it's relating one RDA entity to another RDA entity. And the reason why we have the canonical element set is that it can be used to support implementation scenarios that are not linked data, that you can take the information present in the canonical element set and you could use it, let's say, in a relational database implementation, RDA. So then the other two parts of the element set structure are the data type and the object element sets. And these are intended to support linked data applications. So for the data type element set, the range for those elements are an RDFS literal. And then each data type element is linked to its canonical element via a subproperty relationship. So for the object element sets, the range for those elements are always an RDA entity. And we only provide in the object element set those RDA elements that have a range of another RDA element. So in other words, we only do it for relationship elements. We do not do it for attribute elements in the object element set. Within the object element set, we have an OWL inverse property provided for every element. So we know that which property is an inverse of which. And then each object element is also linked to its canonical element by RDFS subproperty of. And the object element set is intended to support applications that wish to make use of smart data. So to show this in graph form, here we have three different properties. One is has screenwriter person, which is the canonical version. Then we have a data type version and an object version. So once again, with the canonical property, there's no range. It's an RDF schema only. And it could support, as I said, a relational database implementation, or you could use this for bib authority data, or you could use it for flat file data, also known as a catalog card. The element on the left is the data type version of screenwriter, has screenwriter person. As I said before, its range is an RDFS literal. Its use is for linked data, and you're specifically identifying that this is not a object, but a literal. And you would use this for dumb, what we call dumb string-based data, meaning that once you get to a literal, you can't go on, that there's nothing else to link to. You have reached the end of that particular node. And then finally, on the right, we have the object property. As I said before, its range is an RDA entity. It has an OWL inverse, and it's used for linked data, and namely data that is smart, so that you keep the graph going, so to speak. So if the object is an IRI, then you can keep on saying more things and more things and more things about that IRI. And as I said before, the canonical element of screenwriter person is related through RDFS subproperty of through screenwriter person and through the data type version of screenwriter person and the object version. So all of these are linked. So why would we want, so why this specific structure? As I said before, the canonical, the data type, and the object element sets, they're maintained separately. So why do we want to maintain them separately? Because people want to use different element sets for different things. So the canonical element set serves as the basis for the other RDA element sets. So here you can see the IRI for the manifestation canonical element set. Then we have one that is for the data type, and we just add on data type, and one for the object, and we added on object to the end of that IRI. Now, within each of these object sets, the element identifier is the same. So for this particular one, element P30267, it's also P30267 in the data type set and in the object set. So the reason why we do this, it allows for an RDF schema implementation of RDA to be upgraded to OWL by, in part, substituting in the smart paths without altering the element identifier. So this is an easy way to take data that maybe you only use the canonical element set, but you want it to be richer to be used in linked open data. So you can identify properties that should be data type and which properties should be object properties. So moving on to the value vocabularies. These are the vocabularies used in RDA Toolkit to provide the values for selected elements. These are represented as SCOS vocabularies. And like with the element sets, they also support multiple implementation scenarios. So the labels and notations can be used as strings, and they support the structured and identifier recording methods. And of course, the IRIs for concepts in the value vocabularies are used in linked data applications. So this is an example of a value vocabulary page in the RDA Registry. This one is for RDA content type. It is the same navigation as for the element sets. So there are various translations available, and that can be viewed, and more information can be found about each of these by clicking on the double arrow. So now I want to talk about the semantic coherency of the RDA element set. And this is where we use linked data to link everything together. So all the RDA relationship elements exist in a semantic matrix with one another. So for each of the 13 entities, which are RDA entity, work, expression, manifestation, item, agent, collective agent, family, corporate body, person, nomen, place, and time span, each of these 13 entities are related to the other 13 entities through high-level relationships. And those take the form of has-related RDA entity of RDA entity. So there are 169 high-level elements, so that's 13 squared. So each high-level entity is the top element for all other relationship elements within each entity. And here I've provided a snapshot of the work elements and how they're organized. So at the top of the work elements is that we have has-related work of work. And then a subproperty of that I've selected has transformation. There are many other subproperties. A subproperty of has transformation is has transformation by genre, followed by has derivative work, and followed by is abridged as work. So is abridged as work is the bottom of this particular hierarchy. And we can go up successively in the hierarchy until we get to the highest level that we possibly can. This slide is an example of how we provide semantic coherency for the agent relationships. Once again, remember we have agent that has two subproperties, collective agent and person. And within collective agent, we have further two subproperties, family and corporate body. So the diagram at the right shows how we relate each of these agent relationships to one another. Briefly, each agent relationship is related to its broader agent, as well as its broader relationship within a specific agent hierarchy. So if we look at the diagram on the right, at the very bottom, we have the relationship has screenwriter person. So it's related to its agent counterpart in the hierarchy. It's a subproperty of has screenwriter agent. And on the left, it is also a subproperty of has author person. Looking at has author person is a subproperty of has author agent, but it's also a subproperty of has creator of person of work. And basically you can work your way up through this poly-hierarchical scheme until you get to the absolute top of the hierarchy, has related RDA entity of RDA entity. So why do all of this? Why do we want semantic coherency? The reason why we want it is because it allows for different linked data applications of RDA to talk to one another at different levels of granularity. So here I've provided an example of what I mean. So here we have two different works. We have my work and we have her work. My work has a creator agent of work, Damian Iseminger. Her work has an author person, Beth Iseminger. So we can make certain inferences about Damian Iseminger and Beth Iseminger because of the relationship hierarchies. because an author person is an author agent, is a creator agent of work. And the inference is that Beth and Damian Iseminger are both agents and that they are responsible for creating works. Now, notice that what we cannot say is that both Damian Iseminger and Beth Iseminger are persons. The best that we can do is we can say that they are agents, because one is using a coarser element, creator agent of work, and one is using a more specific element. And also, we can't say that Damian Iseminger is necessarily an author. We can only say that he's a creator, and consequently, all we can say is that both Damian and Beth create works. But what we can't say is that we know for sure Damian is an author. So as you can see, the choice of how granular you are will affect how different applications of RDA can talk to one another. But there's always a basic level of semantic coherence. So we know that RDA doesn't live alone, that there are other ontologies out there. And in the spirit of linked open data, the RDA Registry provides maps and alignments to other ontologies. We provide a map to IFLA LRM, which is what RDA is based on, the Dublin Core Terms, the Mark 21 formats, namely the bibliographic and authority formats, and the RDA Onyx framework. So to provide you with some working definition, a map is a set of RDF triples representing the semantic relationship between two element sets or vocabularies. We use RDFS subproperty of or RDFS subclass of in our mappings, and we use these even if the property or class could be semantically equivalent. And maps are based on alignments. So an alignment is a general relationship between two element sets or vocabularies that may ignore the precise semantics embedded in the vocabularies. We provide this just in tabular format, and it enables RDA metadata to be used in non-linked data applications. So to show you some examples in the registry, this is an RDA map from the RDA classes to IFLA LRM. So if the map is not too big, we do try to provide an example of what that map looks like. And then as you can see, we also provide for download. So you can get it as a CSV file or an NTRPL format or NTurtle. There's also a link to the equivalent alignment. This is an RDA alignment page from the registry, and this is for the RDA elements to IFLA LRM. And once again, we've provided an example of what an alignment looks like. You can only download this as a CSV file. And then we also provide a link to the map from RDA properties to IFLA LRM. So the reason why we have these maps and alignments is, as we said, we can take RDA data and we can say that, oh, this RDA data has an equivalent over here, either usually as a subclass. And now I'd like to talk a little bit about transformation. So we do have what's called the unconstrained element set, and that allows data produced according to RDA to be used in applications that do not require the LRM semantics. So the unconstrained element set has no domains or ranges defined. The work, expression, manifestation, and item properties from RDA are dumbed up to generic resource properties. So for example, the elements in RDA has title of work, has title of expression, are combined into one element in the unconstrained element set called has title. For the agent, collective agents, families, corporate bodies, and person properties, those are upgraded, not upgraded, they are dumbed up to generic agent properties. So has author agent, has author person, etc., just becomes has author in the unconstrained element set. As before in the RDA registry, we have a set of unconstrained, we have the unconstrained properties. These are freely available for download, and you can see the various unconstrained properties. So we do provide a map in RDA vocabularies in the RDA registry from the RDA element set to the unconstrained element set. So I want to caution you that unconstrained elements, they are not RDA elements. The whole purpose for them existing is to take RDA information and transform it into something that can be used in a non-RDA application, because that application may want to make use of the data that was used, that RDA was used to produce, but it doesn't need the precise semantics. It doesn't need work, expression, manifestation, and item. It just wants the information. So the unconstrained elements are a way of taking RDA data and transforming it into something that non-RDA applications can use. Then I should also caution that transformation is a one-way street, that you can go from RDA to non-RDA elements, but there is no way to go from the non-RDA elements back to RDA without having a loss in fidelity. Because RDA data that goes from RDA to the unconstrained set is basically dumbed up to something that is not RDA. We could transfer it back to something that is RDA, but you'll lose a lot of the meaning that you had initially. So this is an example of a turtle map that is showing the relationship between RDA agent properties and unconstrained properties. So I just put this up here as an example, and this is always intended for developers to use, not necessarily for catalogers to interpret. So I will end the presentation by showing, how all of this infrastructure could be used in a potential cataloging workflow into the future. So up at the top of this diagram, we have our cataloging environment. And one could argue that in this environment, we want to catalog just using pure RDA. We want to use the pure RDA element set because a cataloger can look at the toolkit, see the element, okay, that's the element, and here's the value that I provide. So there's no translating. You just do RDA as RDA, and you don't worry about how do I put it into Mark 21, or how do I put it into Unimark, or how do I put it into Dublin Core. You just catalog in RDA. And this could be in a local environment or could be in a shared utility. Then from that environment, you could have various outputs to get what you want, So you could decide, or an application could decide that, hey, I would like the RDA metadata description set that was generated in the cataloging environment. I want that in OWL. And that could be one of the outputs. Someone else could come along and say, hey, I want that same information, but I really only want it in Dublin Core. We could do that. Another application come along and say, I really don't care about LRM. I really don't need it, but I want that data. So we could be transformed into the unconstrained elements, and those unconstrained elements could be transformed further and further. Basically, I'm arguing for an environment where you catalog in RDA, and then your outputs are into whatever you want for your application. And that could include something like BibFrame. It could include another application. So we have reached the end of my presentation, so I am open for any questions or discussions, and I'd like to apologize for my late attendance. I was having trouble logging in, and I'm more than happy to stay several extra minutes past 1, say till 1:15. So thank you for your time. Okay, so we do have one question. This comes from Thurston Young. The question reads, do the unconstrained URIs have no data type or object equivalence because they are dumbed up? Okay, so to answer this question, there is no reason why you couldn't have data type or object equivalence in the unconstrained URIs, but as Thurston has alluded to, that would entail defining an object defining a range in the unconstrained element set. We're basically wanting the unconstrained element set to be as open as possible for people. And so because of that, we don't say anything about a domain and we don't say anything about a range. So it's just basically to make RDA data available to people who don't want to have the RDA semantics. Okay, the next question comes from, and I'm very sorry, it comes from Theodore, and I had trouble pronouncing last name, so I apologize. Karen Takos. Are there any plans to republish the relationship matrix? And I assume what Theodore is referring to is that there was a, within RDA Toolkit in its development, there was an idea that we would provide a graphical interface for navigating the relationship matrix. There was also a separate matrix that was a text-based that showed all the different properties and how they were related to one another. This became a development problem that the relationship matrix was unable to be generated correctly. So in order to release the toolkit on time, we took out the relationship matrix. There's no reason that we couldn't go back and try and do it and make it a development priority, but that's something we will need to discuss with the RDA development team. So thank you for your question, Theodore. Let's see here, we'll move. Okay, are there other questions? Feel free to speak up or type in your question.
In the time that's, while someone's typing here, Damian, I'll just add, this session has been recorded and I will be posting the recording as well as Damian's slides in the next 24 or 48 hours. So everyone can look for that. Here, another question did come in.
Yeah, let's see here. This is a question from Melanie Wacker. The question is, are there plans to create an alignment with BibFrame? Yes, there are plans in the technical team working group to do a alignment and a map. It's just a matter of priorities and getting the work started. But we're hoping to start it at least by this fall, and hopefully we can start to publish certain portions of a BibFrame alignment so that, and we would put this in element reference in the toolkit. So yes, there are plans, it just hasn't really begun. Thank you.
I'm going to jump in one more time. This is James Henley, Director of RDA Toolkit. I just wanted to kind of jump in on the relationship matrix question, and that while there are no immediate plans to rebuild the relationship matrix, especially the way it was before, because it was a very complicated process. It was very difficult to generate. We do provide within entities the ability to go in, and if you look at an entity file at the bottom in the elements list, you can refine that to kind of see all the relationship elements between a domain and range. So that is a alternative functionality for the relationship matrix. And we do have hopes of we still have hopes of building a graphical browser for the toolkit that will graphically represent relationship matrix and attributes in the entire structure of RDA.
All right, we have another question. This is from one of the attendees. It says, what happens when crosswalks are not simple one-to-one mappings? For example, when a single RDA property maps to a more complex structure in a target ontology. So we do this already, where there are multiple mappings available for a single RDA property. This happens with MARC bibliographic. because as you know, Mark infamously or notoriously, depending on your point of view, often provides multiple ways of recording the same information. So for example, something like language of expression. This can be indicated in the 008 as a code. It could be done as a unstructured note in a 500 field, for example. You could use an identifier, you could use an ISO code. So there are multiple ways of doing this. And so the mappings from RDA to Mark Bibliographic reflect this. So it's not as simple as turning it around, because you could see what it's mapped to in Mark Bibliographic and then flip it around and know what in Mark Bibliographic goes to RDA because of how different they are. So yeah, we do map to multiple property. When a property in RDA can go different places, we map it to all those places. Let's see here. The next question comes from Syed Mahdi Tahera, and I'm sorry for the pronunciation once again. It says, why are other RDA VSs, such as relationship designators, Appendix J, etc., are not based on linked data still? Well, actually, they are completely based on linked data. Let me go back to in my presentation very, very quickly here. Let's see here. This is the page for the RDA value vocabularies in the RDA registry. This is all linked data. These are SCOS vocabularies. So every single one, I'm sorry, let me back up. This is the value vocabularies. Let me go back further. I realized I wasn't, let's see here. Okay. Actually, I don't have an example of it up, but all of the relationships in Appendix J are now elements in their own right in the new RDA toolkit, in the official version of RDA toolkit. So if you look in Appendix J and you see the relationship designator author, that is now the relationship author agent in the new toolkit. Or if you were to see for a work relationship element, for example, in Appendix I, something like libretto for work, that sort of element, that is also now its own relationship in the RDA toolkit and has a separate page. So all of those relationship designators in Appendix I and Appendix J in the old toolkit are now linked data vocabularies, and they're used that way in the new RDA toolkit. Okay, moving on to the next question. Thank you for that. I appreciate it. Renata asks, could you explain the role of an application profile in this environment? Yes. So an application profile is simply a way of specifying in a very condensed version which elements we are going to be using in our application of RDA, how we use RDA, which elements in RDA we will not be using, which ones are repeatable, which ones are mandatory, and then the recording methods. Do I record it as an unstructured or a structured or identifier or an IRI value? So those application profiles could be put into a tabular profile. For example, there's the Dublin Core application tabular application profile that is being worked on. And we could use something like that as a modification of that. In a tabular format, we could present, we're going to use these elements and not use these elements. So the hope for the future is that we could take a tabular application profile and that we could plug that in. You could take your application profile and you could plug it into RDA Toolkit at the information you get back, you would only be able, there would only be available for display those elements which you said could be used. Or it could be that you still want to see everything, but maybe the page could dynamically say, this element is not authorized for use in your application profile, for example. So our hope is for the future is that users could create their own application profiles based on templates that the RDA Steering Committee would provide, and that users could come up with the application profiles that work for them. And just some examples off of the top of my head, maybe you are you're a specialized library and all you catalog are music materials, for example. I'm a music cataloger. You could go through and select only those elements in your application profile that are related to music or will have some sort of relationship to music. And you could create a profile that way, and you would just get back what you need for music cataloging. Or you are a small library and you only want to make use of a certain number of elements. You could submit an application profile or use one that someone else has come with and say, hey, I only want to see RDA viewed in this way. So that's the hope and how application profiles would work into this. One of the attendees wanted to mention that there is ongoing work being done at the University of Washington to map the RDA ontology with BibFrame. So, of course, the RDA Steering Committee and the technical team is always looking for. We don't want to duplicate efforts, so thank you for that information. All right. The time is 1:05. Are there other questions? This is another question from Renata. What is the time frame for being able to use application profiles and toolkits? We don't have a timeline right now because in order to use them in the toolkit, we would need to do some development work. So it is on our radar. And we might be doing some experiments in the future to maybe build some profiles that they would be handcrafted for the toolkit. Presumably we wouldn't do that in the future, but to give everyone a flavor of how an application profile might look in RDA Toolkit.
All right. I think we should end it here, but I want to thank
I
Damian.
wanted to.
Oh,
yep.
Go ahead.
Oh, just real quick, Renata mentioned that they have a first draft AP ready to go. Feel free to use as a test case. Thank you, Renata, and we might be in touch. So thank you very much.
All right, great. Thanks, Damian, for this excellent presentation. And again, our apologies for the delayed start, but the recording will be posted, and as well as these slides. And I hope you all enjoyed it and found it as informative as I did. Thanks, Damian. And thank you, everyone.
Thank you. Everyone have a good day.